Hi everyone, and welcome to section 8.3, which deals with surface area, which is basically the area of surfaces. So previously we were looking at area of just two-dimensional objects, but now if we have a three-dimensional object, we can find what's called the surface area. And why is that helpful? It's helpful, let's say for instance you want to know how much wrapping paper you need to use to wrap a box, or there's many applications for this. So the best way to kind of think about it, so let's get into it here. Here we have what's called a rectangular solid, okay, because it's a rectangle, it consists of rectangles. And when we want to find the surface area of this, what exactly are we doing? So we have here, let's kind of take it apart a little bit. So I want to show you what this means. So let's say here you have the front. If I was to just split all the sides apart, so you have the front and the back, and then you have the top, you have the top part here, and the bottom part, okay? Sorry, the drawing is not perfect, but you guys get the idea. Plus, and then the sides, right? You have the one that goes in the back here, and then the one that goes the other side, right? So essentially you have 1, 2, 3, 4, 5, 6 faces, right? They're all different, okay? So if you have that the case, so let's say this solid is three-dimensional, so you have a width, a length, and a height, right? So for the front and the back, they have the same dimensions because they're basically the same thing but on opposite sides, okay? So you have the base would be W and the height would be H, so you can kind of see that here. And then on the top here, you have a base of W and then you have a length or a height of L. Okay, so that would be WL here. This is an L, sorry. WL, okay? And then you have the sides where you have this part right here is the height and this part is L. So this would be HL. HL, okay? So why are we doing this? Because I want to show you where the formula comes from. So the total area is going to be twice this, plus twice this, plus twice this, right? So the area of the whole thing, it's going to be 2 times W plus H times H, plus 2 times, because there's 2 of them, WL or LW, plus, and then this one is 2 times LH. So that's pretty much the same thing that you see here. That's kind of just, maybe they put H in front of the W. It doesn't matter. Potato, potato. But the idea is that for any rectangular solid, you can just, using those 3 dimensions, L, W, and H, length with height, you can plug it into this formula and you get it. Okay? So let's go ahead and do one. Find the surface area of a box with length 3 inches. Width 4 and height 5. So we can go through the whole thing where we take the area of each side and find them and then add them all together, or we can just use the formula, right? The surface area, SA, it's 2LH plus 2HW plus 2LW, okay? Now that we know why it is, we just go ahead and plug everything in. So that's going to be 2 times 3 times 5 plus 2 times H is 5, W is 4, plus 2 times L is 3, W is 4. Okay, that's going to be our total surface area. So let's go ahead and plug that in and make sure that you are mindful of your signs. Well, I mean, we could probably do this mentally as well. But let's try. So this is going to be 2 times 3, 6 times 5 is 30 plus 10, 2 times 5, 10 plus times 4 is 40 plus, and then this is going to be 6 times 4 is 24. So we didn't even really need the calculator. 30 plus 40, 70 plus 94 inches squared because we're talking about area. Okay? So that's it for this example. Now, let's talk about the surface area of a cylinder. Okay, so let me go ahead and show you first. Let's go ahead and, you're going to have to forgive my drawing here. But let's say you have a cylinder, okay? Imagine like a can of soda or something, okay? You have a circle on the top and a circle on the bottom. Here's the center. This is the radius. This is going to be exactly the same, right? the radius. Sorry, this drawing is not perfect, but you guys get the idea. Okay, this we'll call the height. Okay, now if I was to take this apart, let's say if I was to remove the top and bottom of the can and just kind of like open it up like the label, right? So that it would look something like this. You have the top part, you have the bottom part, and then you have the label part, okay? Where this top here is the height, but what's this distance? Since I took this apart from here, this top distance is actually the circumference of this circle. Do you guys see that? So if I was to unroll it, like if I was to take a knife and cut it up here and then cut it over here and unroll it, I would create a rectangle where the top here, this base here is going to be 2 pi r, because that's the circumference of the circle that we started with here. So then this is of course r, and this is r. Okay, so what would the area be then of this cylinder here, top, bottom, and the side, right? So that's going to be the surface area is going to be 2 times, because there's 2 circles, right? Formula for area of a triangle is pi r squared plus, and then here you have 2 pi r for the base times the height, which is h, so 2 pi r h, okay? And that's how we get the formula for surface area of a cylinder. Super fun, I know you're so excited. Okay, and the formula will change depending on if it's open on both ends, closed on one end, or closed on both ends. What we just derived was closed on both ends, right? 2 pi r squared plus 2 pi r h, because this 2 is the top and bottom. But if you only have one of the circles, then you're going to do the label part plus one of the circles. And then if you have an open cylinder, right, like a straw or something, then that's just going to be the label part, right? The part that we unroll, the 2 pi r h. So that makes sense here. All right, so let's do find the surface area of a closed cylinder. So right away, we know that the surface area is 2 pi r squared plus 2 pi r h. And it gives us that it has a radius of 2 and height of 8. Okay, so now we just go ahead and we plug that in. So we get the surface area is equal to 2 pi times 2 squared plus 2 pi times r, which is 2, times h, which is 8. Okay? So I can give this answer in 2 ways. I could give it as an exact, or I can give this as a decimal. So let's go ahead and first do it exact, and then I'll show you the decimal part. So 2 times 2 is 4, and then 4 times 2 is 8. So this is actually 8 pi plus, and then here 2 times 2 is 4 times 8 is 32 pi. We can't forget about the pi here. So now the way that you deal with pi, you can go ahead and add them together. You know, you have 8 of them here, 32 of them, so together we have what's called 40 pi. So that would be the exact answer, feet squared. But if you wanted to write that as a decimal, you would have to, of course, put 40 pi, and then you can, you know, you can approximate that. It's 125.6, or, you know, 125.66 or 0.7, because of rounding, right? The one next to the 6 is 6, so we need to round up, feet squared. Okay, so either one is fine. Just depends on the problem. Okay? It says, give me an exact answer, and then you need to give in terms of pi. All right, so surface area of a sphere, I'm not going to get too much into the why it is, but I am going to give you the formula. And the formula here is 4 pi r squared, okay? Yes, so let's first talk about that. So what is the r here? The radius is from the center of the sphere out, okay? And what is a sphere? It's basically if you take a point in space and a fixed distance r, and we were to find all the possible ways that r could come out, and then we made, you know, we either filled it in if it's a full sphere, or if it's empty, you know, if it's just like a ball, then that would create this sphere, you know, would create a sphere. Okay, so we have this and this, and then, you know, so that's kind of what we see here. Okay, sorry, the drawing's not perfect, but I think you guys get the idea. Okay, so that's it, yeah. So 4 pi r squared, not too bad. So that's, let's see, below this figure is composed of a right circular cylinder with half a sphere on top. So the cylinder has a radius 5 inch and height 10 inch. Find the surface of the figure assuming it's closed on the bottom. So this one is kind of like, what are we really doing? We're finding the surface area of a cylinder with an open, with one gone, right? So we say open on one end, so cylinder, open, and on one end, cylinder, plus, and then half the surface area of a sphere, right? Because it's a hemisphere right here on the top. So basically what we're finding here is this here where this is filled in and the outside is filled in but not the inside, plus, and then the sphere but half of it. Okay, so a hemisphere. Okay, so that's kind of, if we see it this way, we can go ahead and find the surface area. Okay, so remember, what is it if it's closed on one end? So that the formula for that, for closed on one end, is going to be pi r squared plus 2 pi r h, right? Because 2 pi r h is the label and the pi r squared is the circle on the bottom, plus, and then we already know what the formula for a full sphere is, so for a hemisphere it's just half that. 4 pi r squared, okay? So we don't even have the dimensions yet, but we're kind of getting the idea. We do know on the side we can write a radius is 5 and height is 10. So we can simplify this a little bit more if we wanted to. Pi r squared plus 2 pi r h plus, and then half of 4 is 2, so 2 pi r squared. These are like terms, right? So technically what we're going to do, the surface area here is going to be 3 pi r squared plus 2 pi r h. And then we just plug in 5 and 10. Now, did we have to do this bottom calculation? No. Could you have just plugged it into here and found them separately? Yes. Okay, so, but you know, just for fun here. So r is 5, so 3 times pi times 5 squared plus 2 times pi times 5 times h, which is 10. Let's go ahead and calculate that. Let's find the exact, and then let's go ahead and find the decimal approximation. So here we have 3 times, 5 squared is 25, times 3, that's 75 pi. Okay, plus, sorry, that's a plus. 2 times 5 is 10, plus 10 is 100 today, pi. So then we can combine these two together as if they were a variable, right? So that would be 175 pi. That's the exact, right? Inches squared, sorry, inches squared. And then if we want to know the decimal, you can go ahead and use your calculator, which would be 549.8 inches squared. Okay? So that's how much material we would need to cover this entire figure if we wanted to. Okay? So that's it for 8.3. Your homework is 1 through 16 all. Good luck, and I will see you on the next video.